Good day, our esteemed viewers. You're welcome to today's class. In our class today, we'll be looking at another set of 5 questions taken from the Consolidated JAMB 2020. And before we continue, please we ask that you please subscribe to our channel for support and encouragement. Thank you. Number 6. What is the number whose logarithm to base 10 is about 2.3482? We have these options on the board. Let the number be x. The log of the number to base 10, right, equals what? Bar 2.3482. Given this, we can say our x equals what? 10 to the power of what? Bar 2.3482. Right? We compute this and we have our answer. This equals 10 to the power of, by law of indices, okay, this is the same as saying bar 2 plus 0.3482, right? By law of indices, we can say this is what? 10 to the power of minus 2 times 10 to the power of 0.3482. This will give us what? 10 to the power of minus 2 times 10 to the power of 0.3482. What would that give us? We're going to use our calculator to compute that. Just to beat time. 10 to the power of 0.3482. That will give us 2.2294. That is 2.2294 and so on. We multiply this, we are going to have what? 0.02294. That is, the point comes backward twice, negative coming back twice, 1, 2. You have 0.02294, and that is our option what? B. Alternatively, we can use the log table. Okay, you find the anti-log of this to give you this. All right, use the log table, find the anti-log of that to give you the same answer. How do you find anti-log? You have bar 2 plus 0. Okay, you have bar 2.3482. Using the anti-log table, you check the anti-log, you go to the row of 0.34, right? Row of 0.34, right? Check under the column of 8, all right, where they intersect. That number there, you're going to have something like 2228. All right, you have this log 0.34 under column of 8. You have this. Then these two, you go to the section of the difference. Okay, difference of 2. Check the difference of 2 under this column and under the row of 34. You're going to have 1. So add 1 to this. You are going to have what? 2229. Okay, this is what you have. Then we replace the decimal point now. You go to the characteristics, you add 1 to the characteristics. Minus 2 plus 1 is what? Minus 1. Meaning you are moving the point here backward once. The point is in here. You still have 0.022. Same thing. All right? 0.02229. Right? Approximately. That's that for number 6. Now go to number 7. Now for number 7, we're told that what factor is common to all this expression? Okay, this, and this. Okay, to find the common factors, first of all, we simplify the expression. The first expression, you have x squared minus x. You simplify, you have what is common? You have x common, right? Factor out x from here, you have x left. Factor s from here, you have minus 1. So for this expression, x is a factor, and x minus 1 is also what? A factor. You come to the next expression, you have 2x squared plus x minus 1, right? You simplify this by factorization. What do you have? 2x squared times minus 1 gives us minus 2x squared. So we're looking for two numbers such that when you multiply, it will give you minus 2x squared, and when you add, it will give you plus x. What are those two numbers? Those two numbers are what? Plus 2x and minus x, right? Plus 2x times minus x is minus 2x squared, plus 2x minus x is plus x. So we replace this middle term with these two terms. We have 2x squared plus 2x minus x, then you have your minus 1, minus 1. Okay, then you factorize each, you pair and factorize. We take this pair, what is common? 2x is common, 2x. You have what left? Factor out 2x from here, you have x left. Factor out 2x from here, you have what? Plus 1. You come to this also, what is common? Minus 1 is common. Factor out minus 1 from here, you have x. Factor out minus 1 from here, you have plus 1. So what do you have now? X plus 1 is here, x plus 1 is here. Factor it out, x plus 1. What do you have left? 2x minus 1. 2x minus 1. So for this expression, x plus 1 is common, 2x minus 1 is common. We go to the last expression. The last expression, you have x squared minus x. X squared minus x, sorry, x squared minus 1. This can also be written as what? X squared minus 1 squared. 1 squared is the same as 1. So you have difference of 2 squares, and this will give us x plus 1, x minus 1. So looking at this three, look at this, looking at the factors now, which is common. X minus 1 is here, x minus 1 is here, but x minus 1 is not here. If you look at the factors, there's nothing common here. Alright, there's x here, no x here, no x here. So there's nothing common. Hence, you come to this, x is not common, x minus 1 is not common, x plus 1 is not common. You have it here, you have it here, but you don't have it here. Alright, hence we have no common factor. And that is option what? Option C. Now move to 8 and 9. Now we have question 8 and 9 on the board. 8 says find the value of p for which the equation equals 0 has equal roots. This is a quadratic expression. We know that given a quadratic expression, let's say ax squared plus bx plus c equals 0. The root is given by what? X is given by the formula minus b plus minus the root of b squared minus 4ac all over 2a. B is the coefficient of the middle term, a is the coefficient of the first term, and c is the constant, right? The constant term. Now, for the root to be equal, it means this is the determinant, right? This must be equal to 0. That is, root of b squared minus 4ac must be equal to 0. All right? If this happens, then we're going to have equal roots. Okay? And for this to be 0, it means b squared minus 4ac equals 0. All right? So if we take that, if we take it to this now, for this to have equal roots, it means b squared minus 4ac must be equal to 0. Our b is the coefficient of the middle term, right? Which is what? Minus into p minus 2. You have minus into p minus 2, right? Squared minus 4 times a. A is the coefficient of the first term, which is 1, times c is the constant term, which is 2p plus 1. 2p plus 1. So when this equals to 0, then the root will be equal. So let's simplify this now. Minus squares, minus goes. You have p minus 2 squared, then minus 4 into what? 2p plus 1 equals 0. Expand this bracket, you have p squared, right? Minus 4p plus 4. You square the first term 2 times, then you multiply the first and second by 2, you have this, then square the second term, you have this. Okay, expand this bracket, minus 4 times 2p minus 8p, minus 4 times plus 1 minus 4 equals what? 0. All right, so what do you have next? You have p squared minus 4p minus 8p minus 12p plus 4 minus 4 goes 0 equals 0, right? Factorize this, p is common, you have p, factor out p from here, you have p left, factor p from here, you have minus 12 equals 0, right? So what do you have next? My p equals 0 or p minus 12 equals 0, right? All right? So here we say p equals 0 or we say p equals what? 12. Hence we have p to be what? P to be what? 0, 12. And that will give us option what? C. Our option C is the correct answer. Okay, now for number 9, we want to find the value of this expression p plus 2q. To do that, we have to, from this equation, get the value of p and q, and then we substitute into this expression. Okay, now first of all, we pass 3/4 through. Remember our law of indices, giving x raised to the power a times, right? If you have given this expression, it's same as saying what? X raised to the power a times b, right? We apply that here. You're going to have a raised to the power 2 times 3 over 4. 2 times 3 over 4 is what? 2 here 1, 2 here 2, 3 over 2. So you have a to the power of 3 over 2. Then b minus 3 times 3 over 4. 3 over 4, sorry, is what? Minus 9 over 4. Minus 9 over 4. Then you have c 3 over 4. All over what? A to the power of 4, b to the power of 4, c to the power of 5 equals a minus p, b, q, c, r. And next thing we do now, we also recall law of indices, division. We have a number, say x to the a to the power of x over a to the power of b, the same as saying a to the power of x minus b, right? So we apply that here. You're going to have for a to the power of 3 over 2 minus 4, b to the power of minus 9 over 4 minus 4, right? And then c to the power of 3 over 4 minus 5, all equals a to the power of minus p, b to the power of q, c to the power of r. Next here now, I simplify the powers. I can add over 1 here, over 1 here, over 1. For a, the LCM is what? 2. 1 into 2, 2 times 4, 8. So 3 minus 8 is minus 5. For b, I have LCM to be what? 4. 1 into 4, 4. 4 times 4, 16. Minus 9 minus 16, minus 25. And then for c, I have the LCM to be 4. 1 into 4, 4. 4 times 5, 20. 3 minus 20, minus 17. Equals what? A to the power of minus p, b to the power of q, c to the power of r. Right? So when I compare the powers now, I'm going to have minus p equals what? Minus 5 over 2. This implies p equals 5 over 2. Then for q, I have q equals to minus 25 over 4. Now I've gotten my value for p and q. I don't need r. So I simplify p and q now into this expression. I'll get my answer. Let me clean wipe this part. So now the expression p plus 2q equals what now? Our p is what? 5 over 2 plus 2 times our q is what? Minus 25 over 4. Right? 2 here, 1, 2 here, 2. I'm going to have 5 over 2 minus 25 over 2. And that will give me what? Minus 20 over 2. Minus 5 minus 25 minus 20 over 2. And that will give me minus 10. And that will is given by option C. So here now, option C is the correct option. Now we go to the last question, which is number 10. Now for the last part of this set of questions, number 10, if sine x equals cos x, what is x in radian? Now recall that our sine x equals what? Cos 90 minus x, right? So if sine x equals cos x, it means that what? X equals 90 minus x. So you have x, this x comes, so you have plus x equals 90. Our 2x equals 90, sorry, right? So our x equals what? 45 degrees. So our s equals to 45 degrees. And also recall that what? Pi equal in radian, pi is what? 1 equivalent to 180 degrees, right? So for 140 degrees, we're going to have our x is what? Pi over what? 4, right? 180 over 4, that is 45. So our x is pi over 4, and that will give us option A. Now we've come to the end of this section. Please and please, we ask that you please support us. If you are watching this video on YouTube, subscribe to our channel, okay? And if it's on Facebook, please share our videos. I'll share the link to reach out to as many students as there are out there. Thank you for listening. God bless you.